This example is of a series circuit where we have three resistors connected to a power supply. But for this problem, we don't know the voltage of the power supply. We know the individual resistances, 8 ohms, 13 ohms, and 6 ohms. We also know the current through this last resistor, the 6 ohm resistor. So if I use the table and I just fill in everything that we know, if I just go in order, so from top around the circuit, I have 8 ohms, I have a 13 ohm resistor, and I have a 6 ohm resistor. And I know that the current through the 6 ohm resistor is 0.54 amps. Something I just wanted to mention in this example is that it's pretty arbitrary what I define as R1, R2, R3. You can change the order. It really doesn't matter too much because you're still going to come up with the same results. The next thing I'm going to do is just take a look what I have, and since I know all three resistors, I can find the total resistance. This is a series circuit, so I just add them up. So 8 ohms plus 13 ohms, that's 21 ohms, plus 6 ohms, that's 27 ohms. So I know that the total resistance in the circuit is going to be 27 ohms. The next thing I can do then is use my current, because again, this is a series circuit. I know in my series circuit rules that the current remains the same throughout. It has nowhere else to flow. So since it has nowhere else to flow, that means all the other currents are going to be 0.54 amps. And then the last thing I can do is just use Ohm's law. And I just use V equals I times R, and I can find the individual voltages along with the total voltage. So if I just multiply them together, so 23 times 0.54, or 27 times 0.54 is 14.58 volts. 8 times 0.54 is going to be 4.32 volts. 13 times 0.54 is 7.02 volts. Then 6 times 0.54 is 3.24 volts. Last thing I'm going to do now is I'm just going to double check, because these 3 volts should add up to the total. So if I just add those up, 3.24 plus 7.02 plus 4.32, I get 14.58 volts. So I did double check and I know that those add up. Something I want to point out that's really important for these problems, especially when you're working on these on Moodle. These ended up being nice. They ended up being 2 decimal places. For some of the currents, for some of the voltages, for some of the resistances, you want to make sure that you round as far out as you possibly can. If you just round to 2 decimal places, if you just round to 3 decimal places, you may not necessarily get the correct answer. The whole goal is to come up with the answer that's going to be within 1% of the correct answer. With the currents especially, since they're so small of values and they're tiny decimals, sometimes 3 decimal places will not suffice. So you want to make sure that you just round out as far as you possibly can, which means if you're just using your calculator, you probably just want to use the previous answer in the calculator when you're coming up with these different calculations rather than rounding as you go along. That's going to be critical when you're solving these problems.